All right, in this lesson, we are going to be solving equations with rational exponents. We're going to start off with some simple examples, and then we will get to some more complicated examples later. Okay, so this first one, this is just quadratic. It's being raised to the second power. And so to solve this, we use our square root property. Okay, and so if a squared equals b, then a equals the positive or negative square root of b. We talked about that with inverses. You need the positive and negative square root. And so the reason for this is because if I just tell you a squared equals 9, you don't know if a equals 3 or if a equals -3, because both of these numbers squared would have given you 9. Okay, and so using that property, this means x minus 4 equals the positive negative square root of 36. Okay, and then I like to go ahead and add the 4 to both sides and put it before the plus or minus because we're going to break it into two cases. And so we know the square root of 36 is 6. And so that means one option is 4 plus 6. The other option is 4 minus 6. So 4 plus 6 is 10. And 4 minus 6 is -2. And so your two solutions are 10 and -2. Whenever you're solving a quadratic, you usually have two solutions. Okay, here we're solving a cubic equation. You're not going to get two solutions. First step is isolate the cube. And so now I have x plus 1 cubed equals 27. Okay, and so now to get rid of this cube, we are cube rooting both sides. And so the cube root and the cube cancel, leaving with x plus 1. And then the cube root of 27 is 3. Not plus or minus cube root, just 3. And then we subtract 1 from both sides, and so we get x equals 2. Okay, so with cubic and cube root, there's nothing weird going on with that. No plus or minus, no domain restrictions. It's quadratic and square root that we have to worry about. Okay, and so in this next one, it's square root. That 1/2 power is the same as square root. So if you want, you can rewrite this equation using the square root notation because that'll help you keep things straight and keep you from missing critical things like square root equal to negative doesn't exist. And so I like to rewrite it in terms of square root just because it helps me from making careless mistakes. Okay, so to get rid of the square root, we square both sides. Okay, the square root and square cancel, giving me x plus 7 equals 36. Then we subtract 7, and we get x equals 29. Okay, just one solution there, no plus or minus. Okay, here we're dealing with cube root. This 1/3 power is the same as cube root. And cube root can equal -3, so it's kind of jarring to see that radical equal to a negative, but for cube root, that's okay. For square root, it's not okay. And so we are ready to go ahead and cube both sides. And then be careful with this. The cube of -3 is -27. When you raise a negative to an odd power, it stays negative. Okay, and so now we're ready to add 11 to both sides. And that would give me -16. All right. Okay, so here we have a numerator and a denominator. And so remember that numerator is your exponent, that denominator is your radical, okay? And this 3, there's no parentheses, so this 3 is outside. And so that 2 in the denominator is a square root, and then that 3 in the numerator is a cube. So I like to put the exponent on the outside, the radical on the inside. Either order is proper, but you'll see why I do that when we start solving this. Okay, so first step is to rewrite it using the radical. Second step is we still need to isolate, and so we need to get rid of that 3 that's outside. So that leaves me with the square root of x cubed equals 27. Now, it's easiest to get rid of this exponent first. So to get rid of a cube, we need to cube root. Okay. So that leaves me with square root of x equals, and then the cube root of 27 is 3. And now we're ready to get rid of the square root by squaring both sides, which gives me x equals 9. Okay, and so notice I got to a square root equals a positive number. Be careful if you get square root equal to a negative number. That's when there's no solution. Okay, the other thing I want you to notice is that it's easier to get rid of this cube because that means I'm cube rooting before I'm squaring. Cube rooting before I'm squaring. You don't want to square then cube root. Could you imagine trying to square 27 and then trying to cube root that? It would be very difficult to do without a calculator. And so something you'll hear me say often is root it before you raise it. Okay, so root it before you raise it to a power. Okay, this is similar, but this time my denominator is a 2. Oh, it's the same problem, only now it's equal to a negative 81. And so first step is I can get rid of that 3. And so now it says square root of x cubed equals negative 27. So now I cube root both sides, which gives me square root of x equals negative 3. And so I included this example because here we were able to keep going. Here we have to stop, okay? We have to stop because a positive square root cannot equal a negative number. This is not part of the square root property. The square root property applies to a quadratic, not when you are given the square root, okay? So as soon as you see square root equal to negative, stop. There's no solution. Square root cannot equal negative. Okay, if you kept going and then tried to plug this, your solution, which would have been positive 9, it wouldn't have worked. Okay, if you put in a positive 9 here, you would have gotten positive 81, not negative 81. So that's another way to check your work. Okay, this next one, now this is different. We have a cube root and a square, okay? And so 3 times the cube root of x squared equals 48. So these are deceivingly complicated. It looks simple with that rational exponent, but you're really doing 2 different functions at the same time. Here we have cube root and quadratic. And so it's easiest to take care of it one at a time so you can really be careful if you have extraneous solution or if you're using the square root property. And so it's easy to get lost in the process. So here we still need to divide by 3 first. That's outside. And 48 divided by 3 is 16. I'm going to check that. Yes. Okay, and so now we're ready to square root both sides, but remember the square root property. And so this means the cube root of x is equal to the positive negative square root of 16. Okay, when you square root both sides to undo this square, it's the positive negative. That's the square root property. Okay, and so cube root of x, we know the square root of 16 is 4. And so now when we cube both sides, we get positive and negative 64. Both are solutions. Okay, and so remember, when you have a 2 up here, you need the positive and the negative to undo it. Okay, so this next one, again, I have a 2 up here, so I'm going to need a positive and negative. I'm going to get 2 solutions. Okay, first step is let's go ahead and isolate the expression in parentheses. And then let's go ahead and write it in radical notation. I have cube root. And then I have all that being squared. Okay, and so by the square root property, when I square root both sides, I need the positive and negative. Okay, so that's positive and negative 2. And on the left, we still have that cube root, and we still have the x plus 2. Now we are ready to cube both sides. So that gives me x plus 2 equals positive negative 8. Okay, and so we're going to slide this 2 over to the other side, put it before the plus or minus, so that we can break it into our cases. Okay, don't just subtract 2 from 8 and say positive negative 6. That is not the correct way to do that, and I see it all the time. You have to break it into cases. Negative 2 plus 8, negative 2 minus 8 gives you completely different answers. In this case, we get 6. In this case, we get negative 10. All right, last one. Let's isolate this expression in parentheses by first subtracting 7, which will get us negative 64. Noticing you're probably going to run into perfect cubes and perfect squares along the way so that we get some nice numbers. Okay, next we have this negative 1 we can get rid of, which is actually really good because now when I rewrite this in terms of square root, it's equal to a positive. And so we want that. Okay, and so this 2 is square root. And then that 3 is our third power cube. Okay, and so now we can cube root both sides. No positive or negative for cube root. Can't say that enough. So just 4. And now I have positive square root equal to a positive number, so we can keep going and square both sides. So x minus 4 equals 16. Add 4 to both sides. X equals 20. Okay, and so the key things we're putting together here, we've talked about them in previous lessons isolated, but when you are dealing with x squared equals some number, you're going to end up with a positive negative square root. So when the numerator of the exponent, that top number of the exponent is 2, you need to include plus or minus to undo it. Okay, so when the numerator is 2, that's when you have to watch out for that. So I'm going to look for some examples up here. The first time we saw that, well, we actually saw it in number 1. We saw a 2 in the numerator. Here we saw a 2 in the numerator, and we had plus or minus to undo it. We had a 2, and we had a plus or minus to undo it. And so whenever your numerator is 2, you need a plus or minus to undo it. Okay, when the denominator of the exponent is 2, I need to check for extraneous solutions. And really what I mean by extraneous solutions in this case is that square root can't equal negative. So you shouldn't even get a solution. You should stop when you see square root equal to a negative. And square root is when your denominator is 2. Okay, so that's why I always rewrite it in terms of square root, so that way you're reminded to check for that. So here our denominator was 2, and we checked to make sure that square root was equal to a positive. Okay, another place our denominator was 2 was 5 and 6. We had to check to make sure square root was equal to positive. Here we stopped because square root was equal to negative.